Well, hello everyone. Welcome to this attempt to make this work well in this recording. I am trying to use a tablet and a pen on this PowerPoint, and we shall see if my handwriting on a tablet is as bad as a screen. Anyway, welcome to the Navigating Linux section. This is going to cover the Linux Essentials Section 2 and then the second half of Section 4. So let's go. Maybe. There we go. Okay, so as a reminder, the link is on the screen for the reading material. Do want to let you know that I don't just keep the material in these slides, just limited to the material that's presented in that Linux Essential. Might give you some more, might go outside of it, but at very least I'm covering the important content of the reading material presented there. And I just wanted to cover a few things related to terminology. So you will often hear, depending on how long someone has been doing IT, the interuse of the words terminal, console, and shell, and just wanted to clarify a few things. So terminal, that's the text input output environment when you go ahead and launch your shell, your bash shell, or your command prompt on a Windows computer, or the terminal program in a Mac. Now when it's text only, you'll often see it called TTY, and in a little while we're going to pull up some commands, show who is on the computer, and you're going to see something called PTS, pseudo teletype system, where if you are remoting into a computer on a shell, you're going to be able to see PTS, and then the TTY is basically the same exact thing, text input output. Now, GUI applications, on the other hand, let me see if I can get my cursor to work here. For GUI applications, that's supposed to be a line. I'm talking about this stuff over here, okay? So, difference between your TTY window, you've got your text, usually default of a white text on a black background. However, when you're running in a GUI system, what you have is, operating at the kernel level, you have this X Windows type of system, or a windowing type of system, that is used to provide the graphics for all the icons and the background and everything else you use in a normal desktop client environment. So in Linux now, Wayland is, we'll call it the default windowing system for Linux. However, it is important to note that some distributions still use Xorg and Xserver clients, and the Linux kernel can support both, as you see there. So generally speaking, when we're doing our Linux administration, we're going to be operating out of a terminal window and a TTY window. Now, console, on the other hand, that is, by definition, a physical terminal connected to a computer that gets you one of those TTY window type things. But it's often used as a synonym for a terminal and a shell. Now, the shell right here is a little bit more than just a TTY or a console. It's more than just an ability to type in things on a computer, whether it's local or remote. It is an interpreter, and really what the shell, and again, we call a shell the console, the terminal, you can call it your bash shell, you name it. It is the platform you're going to use to launch other programs. Everything useful that you type in a shell or in a terminal really is executing other programs. So you're not just sitting there looking at a terminal doing nothing. You maybe want to list some files in a directory. Well, you're going to be running a program called ls, which is for listing this stuff. And then there's different options associated with different programs. There is a flow control to combine different commands in the shell, and that is where the syntax of the different types of shells come in. Now, when you first launch a terminal, it's different depending on which computer you're on. So in the screen here on the right, this is an Ubuntu distribution, version 20, I think it looks like. And you would click on the little search icon, right over here, type in the word terminal or just TERM, and you'll get the terminal. You click on it, boom, and it'll open up. Now in Windows, depending on which versions of Windows you're running, every version of Windows has something called a command prompt, which has some syntax and capabilities of a Linux shell, but it's not all the commands in a Linux shell. You also have something called PowerShell, which is started at Microsoft. It is now cross-platform. It's known as PS Core, PowerShell Core. So you can have PowerShell running on a Mac, on Linux, on Windows, across your entire environment, which is incredibly useful because PowerShell is not only a shell, but it's a very powerful scripting language with its own syntax that is very different than what you see in Linux or Unix. And then, of course, you have you can have a bash window. You can have a bash shell in your Windows client by using something called Windows Subsystem for Linux 1 or 2, WSL or WSL2. And what that does is it emulates a Linux shell in the typical Windows operating system environment, but depending on how you have it installed, WSL or WSL2, you may have some limited functionality. However, in this class of system administration, we're really talking about Linux distributions. And when you're on a server, like you're going to be in our lab server environment that everyone is now able to connect in on, you get the terminal. You get a TTY black and white terminal that we're using to execute our commands. On a desktop distribution, you kind of see, you know, this stuff that's like right over here. So you have a desktop GUI. You'll go ahead and figure out a way to launch a terminal so you can get to your TTY type window. Now, I do want to point out that there's more than one shell. So I just mentioned PowerShell a few minutes ago. Well, PowerShell is a specific type of shell that has its own scripting syntax associated with it. The shells you see here, whoops, this part right there, that was my attempt at a circle. It looks more like a bean. That's okay. So the primary one that comes loaded on almost every Linux distribution by default would be Bash, Born Again Shell. But there are other versions of it. There's Ash, which stands for Almquist Shell, but you don't need to know that. Dash, another popular version, it's a smaller, faster version of Bash. And then there's C Shell and TSH, which are on your free and open BSD variants. Then you've got Corn Shell and Z Shell. Why are there so many? Well, I do have an article linked right here. You can click on it and find out why there are so many. But the key question really is when you go to a shell, which one do you have? And you can type into the command line this command, echo $, and it's a capital SHELL. So let me show you what that looks like. Now, this is on my MacBook Pro, and as we've talked about previously, Mac OS is kind of based on a free BSD Unix-y kind of thing, so it has some similarities with Unix and Linux, but not exactly, because it's its own beast. Well, ever since I think High Sierra, Mac OS has used ZSH as its shell, and previous to that, I believe it was Bash. Now, on my Linux desktop client that I use in my virtual machine, I have Ubuntu 20, and you'll notice up here that I type in echo and then $ uppercase shell, and we'll talk about what this $ and this variable thing is. That's a variable. We'll talk about that for too long. And we are using bash, and bin bash, well, that's the location of the binary, that the program that's going to run so that we get our shell. So let's look at an already open terminal. So here you notice that we have some things. We've got Sal at Ubuntu. So I got my username here. I've got whatever my host name is for the computer. Then I have a location, and then this cursor. This cursor is kind of important. Not the cursor, the symbol before the cursor. So let's break it on down. First, we got the username here, again, Sal. And then my host name is Ubuntu. That's what I named this computer because it's just a VM running on my home computer. My current directory, user lib. It's not your standard directory. If you just log in as a user, you'll be in a user's home directory, but this is where the prompt is right now. And then the shell type for the $, or the £. So for the $, that is a normal user account. However, if you are running as a system admin, a super user, you will show up as root on that host, and you will have the £, for your cursor. So that's an immediate indicator. Maybe you don't look all the way over to the left. It's something that you get used to doing. You're just kind of looking for where the cursor is. But if you see the $, you're logged in as a regular user. £, you are in with administrator privileges at that point. There's two commands that are great to run. One is who and one is who am I. what I show right here on the screen is I'm logged in as a regular user, Sal, at Ubuntu. You can tell because I have the $sign, right? I run this thing. Whoops, that wasn't expected. I run this command called sudo I, which is I'm going to, as a super user, I'm going to run an interactive shell, which actually, and after I type my password, I become root at Ubuntu. I got this nice little $sign there. Now I'm going to type the command who. What it shows is the current user's logged into the system, and it's got Sal, and I was logged in at this date and time when I took this snapshot. Okay, well, okay, so cool, that's fine. Why does that matter? Well, I am root, but I'm root as Sal. So I'm not actually logged in as the root user. I'm not logged in as the root account. I'm logged in as Sal, who has root privileges. So whenever I go to a shell, it's almost automatic. What I'll do is I'll check present working directory. I'll check who, type in who, just to see who else is logged into the machine at that time. And also, you know, if you don't have an easy indicator like Sal at Ubuntu, I'll type who am I just to verify that I know what user I'm in on that computer. Now, when we are typing in the command line, and we're going to be doing it all semester long, all the time, you generally end up with a command line structure that looks like this. So at the top, you have the name of the command. And remember, this is a program that's going to be run. Now, whether it runs from inside the shell that you have launched or outside, we'll get to that in a second. But you're always going to start out with a command you're going to run. And then you have these options, which are optional. And you see some here on the right-hand side of the screen. And I'll go ahead and run through some on a terminal here in a little while. So the options and the parameters, they modify the behavior of the command. So in this case, I'm looking at the ls command, which is list. And there's all these different options I can do to have the output show different things. Like I can type ls-tac-a, and what does that do? Well, it lists everything, including the files that are typically hidden because they're not used by the normal user. But if you want to see them, you can type ls-tac-a. There are short form and long form versions of that, and this is a perfect example right here. ls-tac-a is your short form version of list everything that's in that directory. And then there's ls-tac-tac-all. These are the exact same thing. However, not every option has a short form and a long form. How do you know? Well, you're actually going to go to the man page or the info page for that command, and those are things we'll talk about later. These options can be combined together. So like right here, I have ls-tac-a, tac-l. So I have the long listed all options attached to my list. And notice I can mix the dashes and the dash, so the long form and the short form together. And I could have it just right next to each other like this, ls-tac-al. All three of these will come up with the same output, kind of a preference. And then you can also do ls-tac-la. And in this particular case, the order of the modifiers doesn't matter at all. Arguments, on the other hand, these are things that are required. And I know I'm using an example that doesn't look like I have an argument, because right now, these LS's, all the ones from here down, these do not have arguments. Well, they actually do have an argument. It's an implied argument. It's a default argument that's present. If you run these commands, whatever directory you're in, it will be assumed to be the argument. But in this command up top, I have something different. My command is this ls right here. My argument is the directory that I want to run the command in. I have no options in this particular command. Now, how do you know what to put in for an argument or an option? Well, you're going to go to the manual pages for those commands, and you will see what kind of arguments are required when an argument is required or not. So I mentioned earlier about something along the lines of when you type in a command, like the whole purpose of a shell or a terminal, however you want to call it. You see, notice I say the word shell a lot. I say bash. I go here, open a terminal. I'm talking about the same thing, right? Well, the whole purpose of a terminal is for you to type other commands to get something done in your system administration needs. So when you launch a terminal, there are about 30-ish commands, depending on which shell you are using, that come preloaded inside that shell environment. So, for instance, if this right here are things you should type into your command prompt, and I'll show you that here in a second. You can see it on the screen. But type actually provides some nice output for, is this an internal command that comes preloaded with your terminal, or does it have to reach outside the terminal into some other directory in the Linux file structure to run that command? And if you type it, like for instance, echo is a internal command, you're not going to see any output. It's just going to basically return nothing, and you'll get back to the cursor. However, if you type rm, you'll see the location of the binary, the executable file, somewhere else in the Linux file system. So, as I mentioned, one of the things I like to do is when I go to a terminal or something like that, I'll type in, who's on there, and I'll verify what my current working directory is, things like that. What I'll also do is I'll use the command type or which anytime I start to use a command for the first time or the first few times, just to get a feeling for where those command executables reside. It helps you learn, where the important files are throughout your Linux system. Now, quoting. This is just like things you have to deal with in the semantics of dealing with a computer language such as programming. So everybody who's taking this class has some programming associated with them. Everyone has done a little bit of programming. And quoting matters. Now, I am basing this discussion off of the Bourne Again shell, the bash shell, because it is installed by default on probably the most Linux distributions out there. So there are three types of quotes that matter. So we have the double quotes, we have single quotes, and then there's something called a backtick or a back quote, and we'll get to that in the next slide here. But these quotes, whether when you use them matters because it executes differently on the inside. And you'll see here in the terminal screen me going through this echo, show me the $ path using different quotes. So when you're using double quotes, everything between, so this whole thing here in between the double quotes is going to be treated as ASCII text, just regular old characters, except for some special characters. And in this case, it's going to be this $. What are the other characters, special characters? You got the backslash and you have the backtick. Okay, so those are the most common special characters that you'll probably use in the terminal, that when you have that inside double quotes, when your terminal is reading it, it's going to go ASCII text, ASCII text, ASCII text, ASCII text, ASCII. Whoops, that's a special character that is going to execute some kind of command. And it just so happens that the $ command basically activates and goes to the variable that is associated right here on the $, and you have a variable name. So when you're accessing a variable, you will use the $. And don't worry, we'll talk about variables a little more shortly. Now on the single quote, as the second line shows, got a single quote here and a single quote there. Now what's different? Everything between the single quotes is considered ASCII text. So you'll be going text, 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 text. Oh, you got a $, that's just text. So when you see the output, when you say echo, show me the $ path, what you're going to see printed out on the screen, echoed on the screen, is going to be the word show me the, and whatever is in this path variable, which is an incredibly important environmental variable, which we'll talk about shortly. And you come down here, you get to see this thing called an escape character. And what an escape character does is it removes the special meaning of characters in the shell. So as I mentioned, like in double quotes, I have show me the, and if I just have it printed the way it's shown on the screen, I'm going to end up with the output of whatever is the contents of that path variable. But if I wanted to use double quotes and make it spell out on the screen, show me the $ path, I'd have to put a special escape character there, a backslash, and if I put the backslash there, the terminal would read it and it will go text, text, text. I have an escape character. Oh, I'm going to treat that as just regular text. And then everything that follows would be just a ASCII text character because the $ didn't execute. Now, what about these things called backticks? First of all, where is a backtick? Above your tab key on the left side of your keyboard, you'll see the tilde, the little thing that looks like that. And then above that will be the backtick, which is something that looks like that. I know that was a horrible drawing, but you get what you pay for. All right. So what are these back quotes or backticks? So what happens is with a backtick or back quote, you treat it the same as double quotes, but when you get to the backticks, everything in between is treated as a command to be executed. So at this point, it's when you get to the backtick, it's almost as if you have another shell running inside of the command, pops open at the cursor, and you would type in WC TACL, the left caret, and then etc password directory. And so you're going to execute between the ticks, and then when you get the close backtick, then the rest of it will go to the original command of echo, and then it'll be treated as just plain old ASCII text. So in this particular command right up here, what are the commands, options, and arguments? This is almost a trick question, but it's not really. What you have here is a command within a command. So we have a command, this WC TACL, within the command of echo, and it is within these double quotes, okay? So what are the commands in here? You have echo, that's your first command, whoops. And you have WC, which is word count, is your second command. Now, what are the options? In echo, you have no options, but you do have an argument, which is everything between the double quotes. And then for the WC, your options are TACL, which is you're going to count the lines, basically how many lines do you have. And this caret going to, left caret going into etc password, that is in the etc password directory, I want a count of how many lines there are. So that's how you would read that, and you'll see if you type it into the terminal exactly what you get out of that. And the etc password file, it's an important file we'll talk about later in the class. Now, variables, mentioned those already. I'm going to talk about them again. Everyone, again, already knows a little bit of programming. You already know that you need to worry about syntax, so you need to worry about quoting. Well, now you know how to worry about it in the bash shell. Let's talk about variables. You know what variables do. They store some data for later access. That's the simplest way of doing it. Well, when you open up a terminal, you get something called a local variable. Oops, there you go, right here, a local variable. And it's only available in the current shell. So what I have here on the right is I created a local variable, mylang for my language, and I set the equal sign. So when I am assigning a value to a variable, I will not have a $sign. I'll just have the name of the variable and the equal sign and then whatever I want to put into it. So this variable right here, mylang, is a local variable. Okay, and then I can echo, so the command is echo, and I've got double quotes. Sorry about the weird shape of the quotes, but these are double quotes. And I speak $mylang. So notice what I have here. I have double quotes. We just went over this. Treats everything as text except for special characters. I got a special character, $sign. So what does the $sign do in a variable is while the equal sign is when you're assigning values to a variable, the $sign accesses that variable. And in this case, what will be printed on the screen? I speak, and then whatever the content is in mylang. And notice I have $sign, and then the curly brace, mylang, written. Ooh, my handwriting's bad. But you can also do it as $sign mylang without the brackets. And this is completely up to you. When I was learning, I was taught when you're using local variables, help yourself out by using the curly brace brackets. But when you're using environment variables, these variables you're promoting from local to be used in a shell that can be inherited, then I don't use the brackets and I put the $sign. So what is an environment variable? It's available in a shell and any spawn subprocesses. So if you're in a shell and you're running some additional commands and processes, your environment variables will carry through. So if you want to see what environment variables are currently assigned in your shell, you would type in print env. Now, I created this mylang local variable. I want to actually promote that to be a environment variable that I can use and be inherited in future commands that are run throughout my shell. Well, then I would type the word export. So print env will show what I currently have in the shell for environment variables. I'll export mylang. If you run print env again, you'll see mylang is now part of the environment variables. But then you're like, I don't need it anymore. You can unset it, and when you print the environment variables, you'll see that mylang goes away. So when you assign You're going to use equal signs when you're assigning. Whoops, sorry, that was unnecessary. You use a $ when you're referencing either a local or an environment variable. And again, you can do $ variable without or with the brackets. Both are fine. And so this line right here, etc dir, I created a local variable called etc dir equals single quotes / etc, because I just want to make sure, hey, I want to make sure that that / is not treated as a special character, just in case. Everything in here is treated as ASCII text. Now when I echo it, I am going to reference and basically have with the content of this local variable called etc dir show up on the screen. You will use your variables more when you do things that like shell scripting. And we are definitely going to talk about the path variable right now, as a matter of fact. How about that? So we have the path variable. Path variable is one of the most important environment variables because it stores the list of those directories that contain executables. So if you go right now and you do echo $path in your shell, like it's asked right here, you see a whole bunch of directories separated by a colon, and these are places where executable programs that you're going to call from your terminal window, that's where the computer is going to look to try to find them. Now, why is that useful? Well, later on, when we're writing our own shell scripts, maybe, we want to add a path that's not already, we want to add a directory that's not already in our path variable to say, hey, we're going to write some programs and we're going to put them in a specific location. So like for my classes, or when I'm learning to do Linux things, I'll have in my home directory, it'll be like home/sal/labs. And then I'll create my scripts in there. So I need to add home/sal/labs to my path variable so that when I'm in a command prompt, I can go ahead and execute that program from wherever I am in the Linux hierarchy of files. Okay, so that's why you do it. Now, order does matter in the path command. So as you see when you type in echo path, there's a number of different directories that your computer is going to start looking for binary executable files. If you want to make sure that it first goes to your local directory, you need to make sure that a directory in your local is moved to the front of the path, meaning the far left of the path variable. Now, how do you add it? Well, look at what I have here. I have in all uppercase environment variables by convention. You just all uppercase. It's a convention. It's not a law. Do all uppercase, and then I have an equal sign. So I am assigning whatever is to the right of the equal sign to this path variable, and then you'll notice a $sign. Well, what is that $sign doing? It's accessing what's in the existing path variable, and I'm going to append it using a colon and then the directory of interest that I want to add to the path variable. So go ahead and do that if you wanted to. Go ahead, echo path, see what you have, and then assign this to your, or better yet, assign your home for yourself, your home directory for yourself, just to have it there. And this will become useful, like I said, when you do your own shell scripts later. Now, this is actually a really useful command that when you're learning Linux, and anytime you learn a new command, I just recommend you type it. And you will constantly learn new Linux commands until you do this for a long time. And in that case, you still probably will anyway. You'll always go back to the manual pages, and occasionally you learn some really cool new commands. I like typing the word which, so the command which, and then the command you're interested in. So which ls will tell you what program executes the command that follows. So I'm using the which command. It says, hey, which executable in my Linux distribution that I'm using is executing this thing called the list command or the change directory or group add or whatever it is, whatever command you want to use. And why do I recommend this? Well, I recommend it because it gives you a good opportunity to figure out where things are located and are important. Now, what I have just shown here is kind of like the answer to this question. I want you to go ahead and create a local variable that points to the user local directory and add that variable to the path environment. So I'm going to do my dir is the name of it, and I'm going to assign it using the equal sign and using the user local directory. I do what I just did here on the left, path. I assign it with an equal. I pull the value of the current path with the $sign, append it with, notice, I'm using $my dir because instead of having to type user local, I can change this all I want my dir, and I'll just make sure that when I execute this path equals path colon my dir, I use the $sign, and then when I echo it, you'll end up seeing whatever your current path variable is with user local added to the end, not $my dir. It'll be whatever the value is in that variable. Okay, so my pro tip of the day. Every time you run a command for the first or second time, or until you are comfortable with it, go ahead and type which. So run the which command on that, because it really does help you learn important file locations, which is very useful for when you're troubleshooting things in a Linux computer, to make sure you know where it is. And another pro tip is make your kale easier to throw away as you make it. All right, so that's all I wanted to cover in this particular video. It's about 30 minutes. And there are other videos online walking through different parts of this lecture. If you have any questions, you know how to get a hold of me or your other instructor, Cody. That's it for now. Aloha.